Hi everybody, welcome back from your Christmas break, your holiday, a little bit of time off from school. We're going to get started on our first lesson for IA 8 and 9 today. And today I'm going to start with some measurement stuff, okay? So both grade 8 and grade 9 IA have a measurement part of your booklet that I gave you. If you go and grab it now, it's in the same thing as your drafting. So your drafting 9 was on the front. And you flip back a few pages and you'll see measurement 9, IA 9 measurement systems. Okay, and same thing with the grade 8. Okay, so the base information that we learned today is going to be the same for grade 8 and for grade 9. The questions are different, a little bit more difficult for the grade 9 questions. So I'm going to teach the same thing for grade 8 and 9. I'll post it on both classrooms. And then you'll work on your own sheets there, and we'll go over some answers at a later point. So we're starting with measurement today, and as you can see, imperial and metric are the two concepts that we really like to understand. We want a deep understanding of what they are, how to use a tape measure to measure things in both systems. And you might ask, why do I need to know both systems? Well, I'll give you a little bit of background on the systems first. So imperial is kind of the older system. When Canada was first born back in the late 1800s, land was sectioned off in 1 mile by 1 mile sections, and so that's the imperial system. And so we started out being, imperial was our official unit of measurement. We would measure lengths, weights, volumes in imperial. And then in the, I don't know, about 1960s or so, we started to think and move towards the metric system, basically to improve our trade partners across the world. So Europe and Asia, China specifically, trading with them was much easier when our goods were in metric units. So we started off, our land was sectioned off into 1 mile by 1 mile sections, so we were imperial. You know, I used to have signs that said, you know, Meath Park to Prince Albert was 25 miles. But we have since moved to kilometers. So the reason that we still want to learn imperial, even though it's not our official unit of measurement, is because the US still uses imperial as its official unit. It's one of only a couple of countries in the world that uses it, but it's a big thing for us because that's a big trade partner. And specifically for this class, trades are huge with imperial measurements. So you need to know how to measure in feet and inches, whether you're a plumber, a welder, a carpenter, any of those. You need to know how to use not so much miles and yards, a little bit of yards, but mainly feet and inches. So we need to understand that, how to read a tape measure properly and accurately, which is why we learn imperial. And then of course metric is our official form of measurement, whether it's distance, lengths in kilometers, meters, or millimeters, or decimeters, centimeters, etc., or weight or volume. So you can see the weight and volume in imperial. You got pounds and inches, or sorry, pounds and ounces, which sometimes when we step on a scale, we look at the pounds, not necessarily the kilograms. We're just used to that sometimes. But then also quarts and pints. So when you go in the US and you buy some gas, it's in gallons. Okay, so you've got gallons, quarts, and pints. Here we have it in liters, okay, so we pay for gas in liters, our milk jugs are in liters, etc. So for the purpose of today, we're not really going to worry about the weights and the volumes too much. We're more focused on the lengths. So, and specifically feet and inches. And then we'll kind of look at all of these lengths as far as the metric goes, and they're, generally speaking, the concept of getting from one to the other is the same on this, whereas this is much different. So it's a lot more complicated here than it is there. So we'll touch on those two things. Okay, this is newer, and like I said, the purpose, one of the big purposes that we moved to that was for the trade, reasons of trade with other countries. So, since we still do a lot of trading with the United States, we have a need to know both systems. So if you've got a tape measure in the house, you should go and grab a tape measure right now. Just pause the video, go grab one and come on back. But a really nice tape measure is one that can read in both imperial and metric. So you'll see this one has the inches on this side, and it has the centimeters and millimeters and meters on this side. So it's handy for what we're doing today. Realistically, in the workforce, when you get out onto a construction site, you're probably just going to have a tape measure that reads in inches. But I like having this around the house or in the shop because it does lend itself to being able to do both. You can only read inches on one side, so sometimes you got to flip it upside down depending on where the easier way to hook it is. Whereas a tape measure that has inches on both sides, it doesn't matter as much. It's easier to read up and down, top and bottom. You'll also have certain things like this large level, a 4-foot level here that has an actual ruler on it. And again, in this case, it's got inches and millimeters. And then the more common thing that you'll find around the house is just a simple ruler like this. And so as long as you have something like this around you, as you're doing this assignment, it'll make it a lot easier. You'll probably understand it a little bit better. So, measurement. We'll start off, if you go to your sheet and it has IA8 or IA9 systems of measurement, kind of gives a little spiel on imperial. We're going to start with imperial first. And the first topic is fractions of an inch. And you'll notice that we break up the inch into sixteenths. Most often, when you look at a tape measure, you read a ruler or a tape measure, that inch is broken up into sixteenths. So on this particular ruler, the first inch is broken up into 32s, and then every inch after that is sixteenths. So there's 16 spaces between each inch. On this tape measure, everything right from 0 on out is 16 spaces between 8 and 9, 9 and 10, 10 and 11. 16 spaces. So our denominator on our fraction is always 16. And 16 is not a very nice number, it's not a round number, it's not an easy number to work with, which is what makes imperial a little bit trickier sometimes. So, the first thing that I want you to understand is when we read an inch in fractions of an inch, we always want it in reduced form. Okay, so we want our fractions reduced. Now you've learned how to reduce fractions in grade 5, 6, and 7 math, so you should be good. One thing that you're going to notice, we call the top a numerator and the bottom a denominator. Okay, so the bottom part of the fraction, denominator, the top part, numerator. Now, when you're talking about reducing, every time you see an odd number on top, your numerator is odd, it's reduced. You don't have to do anything else. So if you measured something that was 3 feet 7 and 1/16 inch, you're done. That's in reduced form. That's a good number. You can work with that number. You can record that number on a drawing, on a sketch. You can measure that number accurately with your tape measure on a board. Okay? But if you've got something that's even, okay, so these were odd. These are done. But if it's even, well, an even number over an even number can be reduced. So 2 over 16. Now, let's think back to how we reduce fractions. Okay, so we reduce fractions by dividing both numerator and denominator by a single number. Okay, one number. And this is the part you got to be able to come up with on your own. What number goes into both of these? So multiples of 2 and 6, sorry, not multiple, factors of 2 and 16. What's a common factor? Well, 2 is a common factor. So I have to divide them both by the same number. If I don't divide them by the same number, so if I divided this by 2 and this by 16, well, my answer is not going to be equivalent. It's not going to be equal to 2/16. But if I divide both top and bottom by the same number, it will be an equivalent or an equal fraction. So 2 divided by 2 is 1 and 16 divided by 2 is 8. So this is now our reduced fraction. So if we had a number like 17 feet 8 and 2/16 inches, I would say no, that's not quite right. You need to record that as 17 feet 8 and 1/8 inch. Okay, so that's where we want to get to, being able to label inches or feet, inches, and fractions of an inch properly. So in order to do that, you need to be able to reduce fractions. Now what I want you to do right now is just pause the video, and I want you to complete all of these fractions, reduce them all. And obviously you should be able to figure out that all the odd ones, 1, 3, 5, 7, etc., they're done. You just put the same thing. So 7/16 reduced is 7/16. When you get to the even ones, you're going to have to do some math. Okay? And what you'll notice is that this number will be different sometimes. Sometimes it'll be 4. Sometimes it might be 8. So you'll have a number 2, 4, or 8, you'll notice, when you divide, when you reduce. Okay? And so I want you to write all the reduced fractions beside there. Okay. Now, going on to the measuring in feet and inches. Well, you need to know your 12 times tables in order to be able to kind of go between inches and feet. So, do I need this right now? I don't think so. Okay. So why do I need to know my 12 times table? Well, because 1 foot equals 12 inches. Okay, so that's a very common concept. I think most of us know that, but this is something that we should be able to memorize. Some people might think, oh, well, maybe it's 10 inches, maybe it's 8 inches, maybe it's 16 inches. No, 1 foot, 12 inches. So when you look on a tape measure or on a ruler, you'll notice that this one, it counts 1, 2, 3, 4, 5, so all the way up to 11. And then the next one isn't 12, it's 1F. So 1 foot, 2 foot, 3 foot, 4 foot. Okay, and so every 12 inches is 1 foot. So if I asked you, well, how many inches are in 8 feet? Equals how many inches? Well, you just got to know your 12 times table. So what's 12 times 8? Okay, 96 inches. And that's important sometimes when you're going back and forth on a board, to a tape measure, to a drawing. Sometimes drawings are only labeled in inches and fractions of an inch. So maybe it'll tell you it's 102 3/4 inches. Okay, and it'll ask you to go cut that, or maybe it'll ask you how many feet and how many inches. Well, you need to know your 12 times tables in order to be able to do that. And you'd say, oh, well, this is actually, let's see, 9 feet is 108 inches. So therefore, this one's less than 9 but greater than 8. So I know that this would be 8 feet. Okay, how many more inches than that? It looks like 6 inches and 3/4. So this is the same as this. But in order to have an easier time of it, in order to be able to go between feet and inches easier, I need to know my 12 times tables. And that's what that bottom part there is. So I'm just going to give you some time to multiply by 12 and divide by 12. Because again, maybe I'm given a number that I don't, so in this case, I already had 96 and 108 up here. It was easy to tell where it was. But sometimes I need to divide this by 12. Or get to a number that I know divides by 12, like 120 I know divides by 12 10 times. Okay, so multiplying and dividing by the number of 12 is important when working with feet and inches. Okay, so I'm going to give you a little bit of time to fill in that times table. And then you'll have a better understanding. You'll be able to move between feet and inches a little bit easier. Okay, so that's kind of the imperial system. Now, let me get into those fractions again. Let me blow it up for you a little bit. Okay? So in your booklet here, you'll also notice a couple of pages from now, it gives you a blown up idea of what a ruler looks like, in halves, quarters, eighths, and sixteenths. And again, the one I want you to really have a good understanding of is the sixteenths. And so let's say that I'm going from just 0 to 1. We'll start with 0 to 1. Okay, so halves. Okay, so there's half, and there's the other half. And then quarters would be there. And then eighths would be everything in the middle. And then finally sixteenths, I would be putting marks in between all of those. So now I just broke this 1 inch, obviously it's blowing up big for you to see, into 16ths. Now, what does that mean? How many lines, how many dashes are there? There should be 17 dashes and 16 spaces. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 spaces. And so if we were to say, label this fraction of an inch for me, where are we there? Okay, you always take your marker, your pencil, and you put it on the first tick mark, the start of it, and you only count the spaces, not the tick marks. You start at 0, so you go 1, 2, 3, 4, 5, 6. 6 is our numerator. Over, what does it go over? Okay, it's what's the inch is broken up into. In this case, our inch is broken up into 16ths. So our denominator in this case is 16. Let's say that I had this. 0, 1, and I had this one, which is actually in the same spot. 1, 2, 3. Well, 3 what? What fraction of this inch? It's broken up into 8ths. There's 8 spaces. So 3/8 in this one. This is 6/16 in this one. Okay, and you'll know that from that first page that you did, where you reduce those fractions, you'll know that 6/16 actually equals 3/8. And so we would always want to reduce this to 3/8. But when you're reading that tape measure, when you're first starting out learning how to read a tape measure, and you got a board, let me see if I can find a board here for us. Okay, so you've got a board, and you're first learning how to measure. You pull that tight, and you look and you say, oh, that's not quite exactly on the 19 inches. It's actually 2 ticks over. It's 2 spaces over. So I go 1, 2 spaces. So I need to know what that inch is broken up into total. And I know that every inch on here is broken up into 16 parts. 16 parts. And I just counted 2 spaces out of those 16 parts. And I said it was just past the 19. So the 19, the inch gets drawn full size, and the fraction of that inch gets drawn about half. Each number is half as big so that it equals the same size when you look at the whole thing. Okay? So 19 and 2/16 is the length of this board, but that's not the proper way to say it. That's not the proper way to record it on a piece of paper or on a drawing or a draft or a sketch. You want to put it in proper smallest terms. So 2/16, if you look back to your notes, 2/16 is actually 1/8. So 19 and 1/8. 2 tick marks. Okay, you'll notice 2 tick marks represents an inch. 1 tick mark, so 7 feet. 1 tick mark. 3.5 inches. So this is inches. And this is feet. 1 tick for feet, 2 ticks for inches. Okay, so this would be not 19 and 2/16. We wouldn't label it like that. We'd say 19 and 1/8. Okay, so that's how long this board is. Okay, so that's learning how to break it up into a fraction of an inch. Now, really, what you need to know as a student, what you need to understand when you're first learning to measure items in imperial, in fractions. So let's change this up a little bit. Okay, let's say that this is, you're looking at your tape measure and this says 22 and this says 23. And you've got this board coming from way back there and it goes all the way to here. Okay, and that's your tape measure pulled tight, and it gets right to here. Okay, so I could ask you 2 things. What is this in feet and inches. And what is this in inches? Tell me the length of this board. So this is a pretend board. Okay? So knowing your 12 times table, well, this one's pretty easy. We know that 12, 24 would be 2 feet. So this is not quite 2 feet. So if I'm writing this in feet and inches, I know it's 1 foot and then some inch. Down here, I can see it's between 22 and 23. It's not to the 23 yet, which means it's 22 and some fraction inches. So 22 and some fraction. So let's figure out what that fraction is. Again, we can start here and we're going to go count spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I counted 10 spaces. 10 is my numerator. And what's my denominator? What's it out of? Again, very common, 16. Sorry, I shouldn't have wrote that there yet. 10, 16, this is 10, 16. Okay? Now, I'm missing my inch here. I still need this inch. So 1 foot is 12 inches. Then to get to 22, that would be another 10 inches. So this is 1 foot, 10 inches, because I know that 1 foot is 12 plus 10 is 22. So that should be the same. Yep, perfect. So 1 foot, 10 inch, and 10/16, or 22 and 10/16 inches. Now, this is not quite reduced where we'd want to put it on a drawing, a sketch, a draft. We wouldn't want to have this, something we're going to try to pull a tape measure on. We'd want it in our lowest terms. So 10/16. Again, you would have done this on the first page already, and you know that that's 5/8, but just to, again, show you, 10 over 16, we need to divide it by a common factor of 2, and that gives us 5/8. Once we get an odd number on top, we're done. So this would actually equal 22 and 5/8 inches, or 1 foot, 10 and 5/8 inches. So there's our two answers for this pretend board that I had coming along here. And obviously this comes back here, 21, 20, and so on. That's just our pretend tape measuring board. What I'm going to ask you to do in this assignment here is there's going to be a bunch of pretend boards, especially on those last assignments that look like this. So there's all these rulers, and they're only in inches right now. Okay, so sometimes they're 15 inches, 13 inches, 10 inches, 5 inches. And you'll get into measuring that pretend board, but I want it accurate. Okay, counting the exact number of spaces over 16. They're all over 16 in this assignment, I do believe. I'll double check here. Yep. These are all broken up into 16ths, so you can kind of keep that number in the back of your head, but then reduce it. So I would not want an answer that has 10 and 10/16. I would definitely want 10 and 5/8. 22 and 10/16? No, 22 and 5/8. That's your correct answer. Okay, this tells me you know how to count and you know how to read it from the tape measure, but then this tells me that next level, that level 4 understanding of how to reduce it where you can use it in the real world. Okay? So that is our measurement on imperial. Let's get a little bit into the metric now. And you can pause this video anytime you want, do some of those imperial questions, come back and listen to my metric explanation as well. Okay? So feel free to listen to the whole thing or pause it and come back as we go. So when you flip that over, you get to the metric system. Now, again, it talks about how metric is Canada's official system of measurement. Our speedometers are kilometers per hour, our gas is sold in liters, etc. But the one thing that we want to know and get used to is the concept of going from one a unit to the next. So what we do is we use this ladder, or these steps, I guess we'll call them. Okay, and we need to understand the millimeters is our smallest unit, and we have centimeters, decimeters, meters, decameters, so DAC, hectometers, and kilometers. Okay. And we need to understand that these are actually factors of 10. So 1 centimeter is 10 millimeters. 1 millimeter is 0.1 centimeter. Everything is a factor of 10. And so what metric involves is a lot of moving of the decimal to the left and to the right when you're going between them. As far as measuring goes, measuring is quite simple. Your metric ruler, so let's say that this is going from centimeter number 2 to centimeter number 3, it'll just simply be broken down into 10 equal parts. 5, 10. And this is centimeters, which is equal to 20 millimeters. This is 3 centimeters, which is equal to 30 millimeters. Okay? And so if I was to choose a point like this and say, well, what is A in millimeters and what is A in centimeters? Okay? Well, I can say that this is 2 centimeters. Okay, so this is 2.1, 2.2, 2.1, 2.2, 2.3, 2.4. 2.4 centimeters, or if this is 20, well, 21, 22, 23, 24. Okay, and you should always notice that they're the exact same number, the decimal is just moved. So we all know that when there's a number without a decimal, it's always on the right-hand side. So this is like 24.0 millimeters, which is the same as 2.4 centimeters. And if I said, well, what is that in decimeters? Well, it would simply be 0.24. Well, what is that in meters? Just move it one more spot. Decimal 0.24 meters. Okay, so you'll see this number 24 throughout, and all we're doing is moving that decimal. Okay, so that's where these steps come into play. So again, you'll notice this little bit of a diagram here on your handout. If you're moving up the ladder, you need to divide by 10. Okay, so I went from millimeters to centimeters. I went up, so I needed to take this 24 and divide it by 10, and I got 2.4. And if you're moving down the ladder, you're going to multiply by 10. Okay, so if I go from centimeters to millimeters, 2.4 centimeters, I need to times it by 10, that equals 24 millimeters. Okay, so moving up the steps, you divide by 10, moving down the steps, you multiply by 10. And that is simply to go between units. So if you're given a problem in millimeters and it asks you to solve it in meters, you need to go up the steps. You're going to have to divide your number by 10, 100, 1,000. Okay, so 10, 100, 1,000 to get to there. It's always in that units and multiples of 10. So factors of 10 really play a large part in our metric system. It's easy to, you don't have any reducing, okay? You just count. So with these millimeters, I counted 20, 21, 22, 23, 24. Boom, that's my answer. I don't have to reduce, I don't have to adjust. And the same thing with the centimeters, it's just simply putting a decimal point. So I put that decimal point in there. I don't have to reduce, adjust, I don't have to do any other additional math. I'm just counting spaces. So metric, easy. Imperial, a little bit tricky. You look on your tape measure, and again, the numbers are in centimeters, because you can see there's 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 40, 50, etc. When it gets to a meter, it just has 100, so that's 100 centimeters, up 10, up 100, so times it by 100. 100 centimeters is 1 meter. So what do I want you to understand from this? I want you to understand how to read a metric tape measure. Quite often, knowing the centimeters maybe millimeters and meters, but centimeters is actually quite often a common number. Meters, there's not a lot of decimeters. For the most part, you're not going to see a ton of this stuff in building, in trades work. You'll see a little bit, maybe thicknesses of metal sometimes in millimeters, but it'll also be in fractions of an inch. So you'll come across this from time to time. It's about understanding how to read a tape measure, and then understanding how to move between units, between millimeters and hectometers or whatever. Understanding the divide by 10 each step. So you go up 3 steps, 1, 2, 3, you're dividing by 1,000. You just add a 0 each time. So if I go 1 step is 10, 2 steps is 100, 3 steps is 1,000, 4 steps is 10,000, and you just keep adding zeros for however many steps you take up or down the ladder. Okay? Going up, divide, going down, multiply. Okay, let's have a little peek at some of these questions, and then I'm just going to let you get at it. So the sheet here that I've given you, hopefully you filled out those fractions of an inch and those 12 times tables. At the bottom of our metric system page, it asks you to turn like 333 meters into kilometers. Well, we know that to go here, you're going up 1, 2, 3. So 333. Let me erase this. So the first question there, 333 meters equals blank kilometers. Okay, well I'm going up 1, 2, 3. I got to divide it by 10, 100, 1,000. I got to divide it by 1,000. Do I actually need to take my calculator and divide this by 1,000? No. I need to know that my decimal place is here. Here I'm dividing it by 10, dividing it by 100, and dividing it by 1,000. 0.333 kilometers. Okay, so that's dividing it by 1,000. You're just moving the decimal place one at a time. That's what that power of 10, that factors of 10 does for us. It makes it pretty simple. How about 23.8 decimeters equals blank centimeters? Okay, well I'm actually going down, so I need to multiply it, and I'm only going down 1 step, so I have to multiply it by 10. Do I take my calculator and times it by 10? No, I just move the decimal 1 spot. That's timesing it by 10. 238. So 238 centimeters for that one. So I want you to finish those off. Once you're done those, now that was the grade, what was that? The grade 8 one. The grade 9 one is a little bit different, but same concept. You'll understand the concept when you look. Okay, so you'll finish that. You'll see these rulers on the next page. These are all in inches and fractions of an inch. Now it does say you can cut those out, but unfortunately I photocopied it on the back of that, so hopefully you have your own ruler at home that you can use. Then there's some word problems that I want you to work through. Now, I hope I don't really have to go over this, but I guess I will just for the heck of it. But words like perimeter, area, volume, perimeter, area, volume. I'm not sure we get into volume here actually. No, it's more perimeter and area, but we'll get the concept. So, if you've got a shape of any kind, a room, maybe this is a bedroom, maybe this is a garage slab you're pouring for your garage. Perimeter, remember, is the distance around the outside. So if this is 20 by 30, yeah, obviously this is 20 and this is 30, you just take these numbers and you add them. 20 plus 30 plus 20 plus 30 equals 100. Okay, so your perimeter is 100 of whatever unit I assign. Maybe I assign meters, well probably not meters, but feet, you know, would be a logical one. And you'd have 100 feet. Okay, that's perimeter. Now area, remember the area is this entire area, surface area, okay, the entire surface that you're going to need to cover maybe with concrete. And in this case, you're going to times them. 20 times 30, okay, so that's 600. And now remember when you do area, you're multiplying, you've squared, so you've got square feet, square footage. In this case, 600 square feet You could go 600 feet squared. Okay, different ways to write it, but that would be your area. And then volume, in order to do volume, you need a third dimension. So in this case, maybe we'll have the thickness of this concrete slab set at 1. Okay, it's not, that's pretty thick slab of concrete, but just for the heck of it, that's what we're saying. And volume, we know that it is a length times a width times a height. So in this case, it would be 600 cubic feet. So you could go CU feet, or you could go 600 feet with a cube, with a 3. And that would give you cubic feet. So perimeter is adding the outside. So if you're building a fence, if you're doing baseboards around the top or bottom of your wall, that would be perimeter. Area would be something like flooring, carpet, concrete, well, not necessarily concrete, but maybe fertilizer space on a lawn that you're doing. Okay, that'd be area. And then volume would be something that you have to fill. So like a concrete slab, maybe filling up a container with water for some type of recipe or something, and you need a certain volume. Okay, so that's how you find perimeter, area, and volume. And you'll need to know those concepts for when you get into some word problems with measurement. Use calculators, obviously. Refer back to how to add, or I guess adding fractions. You should know how to do that. So sometimes you're going to have to combine fractions, add fractions. Your calculators know how to do that, but you'll also know how to do that from your math that you've done. If you have trouble with that, by all means, message me on the Google Drive, and I'll go over some of the answers with you later. But for now, I want you to give these a go on your own. Once you've done those word problems, there's some measurement sheets. Okay, and these are all inches. Again, the grade 9s are different than the grade 8s, but for the most part, it's the same type of concept. And let me just double check and have a look at yours. So the grade 9s, their numbers get up a little higher, like 75, 76, 43, 30, etc. If you want to do a real good job, you can break those down into not only inches and fractions of an inch, but do it in feet, inches, and fractions of an inch. And I'll give you one example here for you. Okay, so we know how to do those 3 things because you've learned that in math already. That was just a review. So what happens if this little sheet here has something that's bigger than 12, bigger than a foot? So let's go, and this is the first page of this. It's the 4th one down. It looks like it gets between 75 and 76 inches. Okay, and it gets to about there. Okay, I'm going to break up my inch here first. And it looks like it gets to here. So on the page, this is where the board gets to. Okay, and so we know that this would be 75 and some fraction out of 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, look at that. An odd number, I'm done. Okay, so this would be a good answer. I would accept this. This is something you could put on a drawing. This is something you could measure out on a board. However, I'd also challenge you to put this into feet as well. So now you got to know your multiples of 12. Okay, and so what number that's a little bit lower than 75 is a multiple of 12? And hopefully you're going to say, oh, 72 is a multiple of 12. 6 times. So that means 6 feet. How many inches are left over? From 72 to 75 is 3 inches. And I still got the same fraction. 13/16. This would be a really good answer. I'd like that one too. So challenge yourself to see if you can break answers down into both inches and fraction of an inch, feet, inches, and fractions of an inch. Okay? Give that a go. I'm assuming this will take you, a day or two. Work on it for a couple of days. There's no rush. I'm going to get into some drafting here later on. I'll post another video, but spend today and some of tomorrow working on this measurement, understanding it, going around the house, measure some different things. Maybe go around, measure a table, a cupboard, a bed, a door. record accurately on your tape measure, and then challenge your parent to go and do the same thing. See if you get the same answer. Okay, that'd be a real good way to practice real life stuff where you're going to use that tape measure. Maybe even if you got some old boards or pieces of metal or rebar or something laying around, measure those and be as accurate as you can to that fraction of an inch. And if you want to add a little bit more to it, do it on the metric side as well. So do it in centimeters, okay, and go right to the decimal. So don't just say 23, say 23.2 if that's where it is. And then challenge your parent to go and measure the exact same things and see if you get the same answer. Okay? Otherwise, please get your parent to email me or message me on the Google Classroom, and I'll get back to you as soon as I can with any questions that you might have. We're not going to officially meet at any time, but I'll always be available in the afternoons. I just need you to request that time, and I have no problem helping you out, giving you an answer. And maybe if I start to get a few of the same questions, what I'll do is I'll assign a meet where everyone can come and I can explain the same concept again. But that's where we are today. Measurement. Okay, good luck, have fun with that, and we'll do some drafting next time.